Hey, welcome back to AP3. Today we're starting chapter 4 of AP Chemistry, which is about different types of reactions. So there's two types of changes that you'll encounter, physical and chemical. A physical change is a change in object but not in chemical structure. So for example, if we have ice, right, solid water, and if it melts into liquid water, that would be a physical change. There is no change in chemical structure. It's still water, just in a different phase. The only thing that changed was its phase, right? And another example is like paper. When you tear a paper in half, it's in two pieces, but it's still paper, right? The chemical structure doesn't change. It's just in two pieces. So that would be a physical change. All right, now, so a chemical change is when an object does change chemical structure. Okay, so the bonds of the molecule will break and new ones will form. So, okay, here's an example. Let's say you have methane, right? And let's say it decomposes into um, carbon and hydrogen gas. This is a chemical change because it's changing chemical structure. It's not just changing phase. It goes from CH4 to C and H2. The bonds here are broken and new ones are formed here. So that's a change in chemical structure, which is a chemical change. All right, so these are some common signs of chemical changes. So if you ever get a question and it tells you that any of these things happen, that indicates that what you're dealing with is a chemical reaction. If a precipitate forms, which means that if you have like a beaker that's just liquid or something, and after the reaction, like a solid forms at the bottom, that lets you know that a chemical change took place somewhere along the line. If a gas is given up after a reaction happens, that also lets you know that a chemical reaction happened. And if, same thing for these, if a temperature change happens or if a light is given off, then that lets you know that a chemical change happens somewhere in the reaction. All right, so there's a few different types of chemical reactions that you're gonna see sometimes. The first of these is synthesis. So basically what this is it's two or more reactants combining to form one product. So the template for that would be A, some molecule A plus some molecule B forms AB, right? And an actual specific example would be okay, carbon monoxide plus oxygen gas forms carbon dioxide. Because you have two reactants forming a single product, that would count as a synthesis reaction. The next one is pretty much the opposite of synthesis, is decomposition. So instead of going from two reactants or two or more reactants to one product, you're going from one reactant to two or more products. So the template with that would just be the reverse of synthesis. So AB forms A plus B. A specific example would be aluminum oxide, right? And it would decompose to form aluminum and oxygen gas. This is a decomposition reaction because we go from one reactant to multiple products. It's pretty simple. These are probably the easier reactions that you're going to cover. All right, so the next type of reaction we're going to be looking at is replacement. So, and there's two variants. The first one we're looking at is single replacement. So what that is, it's when one element replaces another in a compound. Let's say we have A plus BC forms AC plus B plus B, yeah. All right. So the A element is replacing the B element in this compound. So that's what would count as a single replacement reaction. A specific example would be zinc and hydrogen chloride. They would react to form zinc chloride. and hydrogen gas. So that would count as a single replacement reaction because the zinc is pretty much replacing the hydrogen in this compound. So that's what we want to look out for single replacement reactions. All right, so the second variant of the replacement reaction is double replacement. So this is the same thing, except two elements replace each other in two different compounds instead of one. So that would look like this. B plus CD forms AD plus CB, right? The A and C elements swap places in their respective compounds. So that would count as double replacement. So an actual example of this would look like this. So you have silver nitrate, and that reacts with sodium chloride, and that would form silver chloride and sodium nitrate. So that's a good example of a double replacement. You can see the silver and sodium switching places in their respective compounds. So that would make it a double replacement reaction. All right, so the last reaction we're going to look at is a little different. This is a combustion reaction, which is when a hydrocarbon, which is a compound made up of only carbons and hydrogens, reacts with oxygen gas to form carbon dioxide and water. So for example, let's say you have methane, only carbons and hydrogens, that's it, reacts with oxygen and that other 2O2, and that would form CO2 and water. So yeah, that's just a combustion reaction. If you see anything with that template, hydrocarbon, oxygen, carbon dioxide, and water, then it's automatically considered a combustion reaction. That's it. It's not super complicated, but just memorize the formula and you're perfect. Hey, that's about it. That's pretty much all for 4.1. All you really need to know is the physical and chemical changes. Physical involves change in object, and chemical is a change in chemical structure. There's a few different types of chemical reactions like synthesis, decomposition, single and double replacement, and combustion. And there are a few signs you have to look out for when you're doing questions that could indicate if you're dealing with a chemical reaction. That's about it. See ya.